Today we're going to be going over how to quote a part. We're going to be quoting this part using a cost plus method. Utilizing cost plus has been a huge thing for Laser Weld over the last 30 years. And it's helped us to secure millions of parts, but most importantly, the long-term trust and relationship for some of our biggest clients. We're going to go over laser cutting, raw materials, welding, and hopefully by the end of the video, you have the tools that you need to be able to quote cost plus. You know exactly what your cost is, and you can stay competitive in an ever-changing manufacturing environment. For those of you who are new to the channel, Laser Weld has been manufacturing here in Texas for over 30 years, and the point of this channel is that we're hoping to share the tips and tricks that we've picked up over the years, and also so that up-and-coming manufacturers don't have to go through some of the struggles that we did. Before we get into the video, I just wanted to give a quick disclaimer. This video is an introduction into Cost Plus. In later videos, we're going to get into facility burden rates, inflation of your burden rate, guerrilla warfare tactics in manufacturing. We can get into all of that, but this video is just an introduction into Cost Plus. We're going to actually start breaking down this part. This is the component that we're going to quote. Before we start putting numbers down, we need to talk about burdened rates. Burdened rate is something you have to calculate using your cost for your area or your cost for your machine. So burden rate varies. With that said, let's go ahead and jump into it. We're going to talk about how to calculate the burdened rate on a machine. This is a very simple spreadsheet. This does not calculate everything. This is just to get you started. If the upfront cost of the machine is $1 million, so we go in, we plug in $1 million, and we say, okay, in 5 years, this machine has to pay for itself. So we got our 5 years. Now we have to go into work weeks. So normally you have 50 work weeks in a year. You can calculate 52, but then that gives you no holidays. So let's calculate 50. If we do a standard 40-hour week, that comes out to it comes out to 2,000 hours a year. So in 5 years, at 50 weeks a year, 40 hours a week, that's 10,000 hours. So once we have that 10,000, we take $1 million divided by 10,000. That gives us $100 an hour. That $100 is just to pay for the machine. So let's look at the same situation, but if you're able to find a used laser at $250,000 instead of $1 million, we run the same calculation. 250,000 divided by 10,000 hours gives you $25 an hour for you to pay off that machine in 5 years. So you see how even if that machine maybe was slower, you have $75 more an hour to work with. As a business owner, you have to make those calculations. Is the machine good enough to do your job and to get it done right and on time? Maybe that used machine works out for you. We have brand spanking new lasers, and we also have some that we've purchased at auction, and they're still making good parts. You have to have these discussions and these conversations to decide, what works best for you in your situation. Like I said, that is just the financial burden rate per hour. You still have to add gas, consumables, and labor. Now that we covered that, we're going to actually start breaking down this part. This has 2 part numbers in it, but this piece, it's the same piece, but it's quantity 2. So just keep that in mind. All of this is made out of 7-gauge material. It is laser cut, and then actually it's super clean. You can't even see it, but this is laser welded. We're going to start by doing the side pieces. So when you're doing the quoting, most shops that have a laser or a plasma or any kind of cutting machine, they also utilize a nesting software. This software allows you to take the cut file for the part and drop it onto a sheet of material. And it'll give you an estimated cut time and how many parts can fit on that sheet. All right, so we have the side frames. If you can look at them, this is a 5-foot by 10-foot sheet of 7-gauge material. So you can see here's all these pieces mixed in there, all right? What I use is the cut time and the quantity on a sheet. So if we look here, this cut time is 1 hour and 25 minutes and 50 seconds. Let's just say 1 hour and 25 minutes, okay? And then if we come down here, quantity on the sheet, 192. So when we're looking at this sheet, an important thing to note is that yes, we can nest 192 pieces, but the chances of us getting 192 perfect pieces is very slim. Let's just go ahead and say 2 pieces out of this batch are scrapped. They're no good. We're gonna go ahead and say 190, and we had 1 hour and 25 minutes or 85 minutes. Now we've looked at the nesting for the sides. We're gonna go ahead and plug it into our spreadsheet. This is just a template. You guys can use this or modify it to work for you, but the concept is the same. So under cut time, we had an hour and 25 minutes cut time. We can turn that into minutes, so 85 minutes. I like to break everything down to minutes. We had 192 pieces. We're dropping that down to 190 pieces. And then a 5x10 sheet of 7-gauge material weighs 361 pounds. Any steel supplier, they will have a chart with all of this information for you, or there's calculators online. In this template, I'm using $190 an hour for laser. This is just an example. You will have to calculate this on your own. You need to calculate the financial burdened rate for your machine. You need to calculate how much you're going to pay for the operator. You need to calculate gas, and you need to calculate consumables. So that gives you your rate for that laser. So we're using 190. This is just an example. The actual laser cost, let's open up the formula so you can see it a little better. So we took 190 divided by 60 to get it down to a cost per minute. And then that's the total cut time divided by 190 pieces. What you're left with is the laser cost for that part is $1.42. The weight of that part is 1.9 pounds. Now we can move over to the raw material cost. We called the supplier, we checked the price on 7-gauge. We're able to buy this material at 43 cents a pound. You cannot sell that part at 43 cents a pound because that is the check that you have to write the supplier. You have to consider cost of money. You have to consider someone's got to touch that material when it offloads from the truck. A good, safe markup on the material only, you could try 8%. So, we mark it up 1.08. So you're selling that material at 46 cents a pound in this example. The material cost per part on that is 88 cents. You add up the laser cost, add up the raw material cost, and you multiply it by the quantity, because there's 2 of them, remember, and we end up with both of these sides together cost $4.60. So now we're going to move on from the sides, we're going to move to the bottom. This one, there is no fine details. This one's going to cut crazy quick. It takes 8 minutes and 47 seconds. Let's just round that up to 9 minutes to make it easy. 9 minutes a sheet. There's 57 pieces here. This is a much simpler part. There's less to go wrong. So if you guys would like, we can go ahead and say 56. We're going to do a really good job. We're going to get 56 out of the 57 off that sheet every time. Cut time, 9 minutes. Quantity per nest, 56. It's 7-gauge, so it weighs exactly the same. Again, we're running at the 190 laser rate. There's your laser cost, is 51 cents a piece. Now, if you take the plate weight divided by the quantity per nest, or quantity per sheet, that part weighs 6.45 pounds gross. So this is a very important part. So if you're looking at this part, we're not selling just this part. You have to sell the entire rectangle of material that this comes out of. If your part weighs 1 pound, it took you much more than 1 pound to produce that part. So that's why we go off the plate weight. If you just put this on a scale, you weighed it, you said, okay, that's my weight, that's your net weight. You need to quote the gross weight. And that's why we take the plate weight divided by the total number of pieces. Okay, again, 7-gauge, the quote came back at 43 cents a pound. We're doing 8% markup on the raw material. Okay, so after the material markup, raw material cost for this bottom plate is $2.99. When we add in the laser processing, we're at $3.50. And there's only quantity 1, so you don't have to multiply it. Now we're going to come over here. And I want to show you something before we get into the welding time. Your welding machine needs can change very dramatically. So if you go out and you buy a top-of-the-line welding machine, cost you $15,000, you don't need a $15,000 machine to weld this part. This one, maybe you could get away with a $3,500 machine, and your burden rate is going to be much lower. So if you take a $15,000 welding machine and you need to pay for this thing in a year, we go through the same calculations. So the financial burden per hour, you need to make $8 to pay for your welding machine. Every single hour though. If you're able to get a $3,500 welding machine, same calculation, you're going to pay for it in 1 year. You need to make $2 an hour to pay for that machine. And again, that's just the financial burden. You have to calculate wire, you have to calculate the rate for your welder, you have to calculate gas and electricity. So even though the machine is much cheaper than a laser, you still have consumables. So now we've gone over the financial burden rate per hour with the welding machine. We'll jump back into the sheet. So here we have our sum of all the parts. So that's the 460 plus the 350. We're at $8.10. So normally I'll take this over to the welder and we'll look at it together. We'll go through it. We'll talk about how to fixture it up. We'll come to a conclusion on, okay, it's going to take 10 minutes to weld that part. If you're the welder, I would highly suggest you even mock it up. I have totally sat in my office and mocked up, picking up the parts, setting them in place, getting the pliers, cleaning the gun, putting the hood down, running a bead, flipping it over, grinding it out. We've totally mocked all that up before with a stopwatch, and we've come up with a time on exactly how long the part's going to take. And normally, we're pretty dead on. I mean, you just have to remember, you got to clean the nozzle, you got to put the hood down, you got to pick up the parts. Don't just pick up the gun and calculate how long it's going to take you to do the bead, because it's the whole thing. So on this part, 10 minutes is sufficient. So we come in here, we plug it in at 10. The welding cost on here, just for this example, I have it at $80 an hour. But again, that's your machine, wire, gas, and your actual welder. You have to do that calculation for your shop, for your area. So we got 10 minutes in welding. Welding cost comes out to $13.33. On this one, we're gonna throw these after paint, we're gonna throw these on a pallet with some cardboard and strap them to the pallet so they don't move, or these are gonna go in a cardboard box. I put 50 cents for packaging. So that gives us a subtotal $21.93. So that $21.93, this is not a theoretical number. This is your actual cost for that component. At this point, if you sell this for $21.93, you're at break even. You've covered all your costs, but there's zero profit. So now we're at the final markup. When you're looking at the part, if they're gonna order 10,000 of these parts over the next 5 years, you're gonna be running this part continually. Maybe a 5%, 10% markup is more than sufficient. Higher the volume, normally lower the markup. So like on this one, this is a medium order. They're gonna order maybe 500 to 1,000 of these at a time, but we may not see another order for a while. So in this example, we're using a 20% markup. If this is a one-off and you're gonna see this part one time, you can either charge all of your setup time, make sure you're billing for all your setup time, or you can do a really high markup. Maybe you need to be at 100% markup. Maybe you need to be at 200% markup if you're only doing this thing once. In the way we've set up Laser Weld, most of the parts that we make are not one-offs. Almost everything has some sort of production volume to it. When you're quoting it, you need to think about that. Are you gonna see this part again? Is this a one-off? Is there a good production volume? And make those decisions. So we had a subtotal of $21.93. We're marking it up 20%, so it's multiplied by 1.2. We're gonna drop down here. So the assembly cost is $26.32. This is after my markup. We've gone through, we know exactly how much this unit cost us. Now we've done the final markup and we can submit it to the customer. Doing it this way has some major advantages. One of the advantages we've seen several times is we'll submit a price to a customer and they'll come back and they say, hey, we'll use this as an example. They'll come back and they say, hey, we have somebody, they say they can produce the whole component for $10.20. We'll look at our quote, say, hey, that's a great price. We have no idea how they're doing it. That's almost below the raw material cost. If they can provide that kind of cost, go ahead. I would highly suggest you use that supplier. Quite often, we've had this happen time and time again. After about 3 weeks, they'll call us back and they say, hey, yep, you were right. The supplier can't provide it for that price. They messed up their quote, and would you like a chance to produce this part? That's happened multiple times. Or if the customer comes back and says, hey, you quoted us $26.32, somebody else is quoting us $25.80, we'll look at our true cost. We have a $21.93. Someone else is doing it for $25. We say, you know what, it's a little tighter margins than we'd like, but yeah, we can match that. By quoting a part cost plus, you know exactly what your cost is, and then you can make an educated decision on your margin. how much you want to make. Is that part worth it or not? So that's one of the huge advantages of Cost Plus, is that you know what your cost is. When you're working up these quotes, I would highly suggest you do it in Excel or some other sort of spreadsheet, and then save it with the part number and the date. That way you always have it. So say you quote this part, you submit it to the customer, you don't hear back from the customer for a year. We've had that. When they come back to you, you pull up your quote and say steel prices, now it was 43 cents back then, now it's 56 cents a pound. All you have to do is just update your material cost. And immediately, we'll go ahead and do that right now. So let's say it was 43, now it's 55. So now this part now costs $27.91. We're very passionate about Cost Plus because it has served us so well over the years. Using this method has landed us millions of parts, over the last 3 decades, and it has been a stepping stone into some of the best industrial relationships that we have. I hope this answered your questions about quoting Cost Plus. This can be applied to any process. You just have to calculate your cost. Having our raw cost has helped us to navigate fierce competition, market changes, tariff changes, raw material shortages, and it has helped us be completely transparent with our customers and help them understand the challenges that we're going through. So I highly suggest you implement this, and it's served us well for the last 30 years, and I'm sure it will serve you well as well. If you have any questions or comments, or you have any content you'd like us to make, please feel free to reach out or comment below. And again, let's make America manufacture again.